Let's talk about how to test for a minimum and maximum point for a curve. So what is a minimum and maximum point? If we have a curve, concave down, concave up, this is a maximum point, and this is a minimum point. So we will use the same equation of the curve we used in the last video, where we tested for an inflection point. The equation of the curve is given here, x cubed minus 6x squared plus 4x plus 12. Now, let's look at the FE handbook to see what it says. To test for a maximum, you find the first derivative and find the value of x for which first derivative is 0. And then you find the value of the second derivative for that value of x. If it's less than 0, it's a maximum point. If it's greater than 0, it's a minimum point. So let's do the first thing. Find the value of x for which the first derivative is 0. So we find the first derivative, which is here. We have 3x squared minus 12x plus 4, and then we set it equals to 0 to solve for x. We can use this equation here to solve the quadratic equation. So we will have minus 12. As you can see, we have a equal plus 3, b equal minus 12, and c equal 4. So we have minus 12, which is b, plus minus 12 squared minus 4 times 3 times 2. This is square root over 2 times 3. If we solve this, we get two values of x, 3.63 and 0.367. So we have found the values of x for which the first derivative is 0. The second condition that the FE handbook says is find the value of the second derivative for that value of x. So second derivative is right here. This is the second derivative right here. We have 6x minus 12. Second derivative of x is 6x minus 12. Now let's find the value of the second derivative for x1 and x2. For x1, we have second derivative of 3.63 equal 6 times 3.63 minus 12 equal 9.78. And let's do for this one 0.367 equals 6 times 0.367 minus 12 equal minus 9.80. Now the handbook says if the second value of the second derivative for that value of x is less than 0, it's maximum. We have less than 0, so this is the maximum. Maximum at x equals 0.367. And it says if the second value of the second derivative for that value of x is greater than 0, it's a minimum. We have here greater than 0, so this is a minimum at x equal 3.63. So maximum at when x equals 0.367 and minimum at x equal 0.36. As we discussed earlier, maximum is this point right here, minimum is this point. If we look at the curve for this equation, for this curve, if we plot the curve, we see that here's a maximum point right here, and this is at x equal 0.3 like we found. and we have a minimum point here, which is at 3.6. So this is a minimum, and this is a maximum. So just to recap, if you have an equation of a curve given, let's say you have this equation given. First you find the first derivative, you set it to 0 and solve for x, for which the first derivative is 0. We found two values of x for which the first derivative is 0. Then for that values of x, you find the value of second derivative. If the value is greater than 0, it's a minimum. If the value is smaller than 0, it's a maximum. Again, just to recap, if we have a curve, this is a maximum and this is a minimum. And this right here, where it changes from concave up to concave down or concave down to concave up, this is the inflection point.